So far, we have only looked at finite series or a finite sum where we only add the first certain number of terms. Now we're going to talk about infinite series where we add the entire sequence, all the terms, onto infinity. Now this seems a little bit odd because it's hard to imagine that you can add something where you have an infinite number of terms. So to break it down for you to help you understand this concept, I'm going to give you an example. So let's say we had the series 1 plus 0.1 plus 0.01 plus 0.001 plus 0.0001 plus 0.00001, where this is a geometric series and my r is 1/10. So I keep multiplying by 1/10. So these terms, as I go on, are going to get smaller and smaller and smaller. So at some point, maybe when we get to A100 or maybe when we get to A200, these terms are going to get so small that it's going to be so insignificant. And then what happens is they're so small we count them as 0, and then we add all the terms before that. So when you have a geometric series and you want to add the entire sequence, there are certain conditions in which you can do that. So if the sequence converges, that means your value of r is between 1 and -1. And you can only add the sequence and have the infinite sum and actually get an answer if your value of r is between -1 and 1. If your value of r is less than or equal to -1 or r is greater than or equal to 1, then your series diverges, which means you cannot add all the terms in the geometric sequence. If you can add all the terms in the sequence and the series converges, then you can use the formula for infinite sum, which is S infinity, and it's going to be a fraction where you take A1, which is your first term, and you divide by 1 minus your value of r. But you can only use this if you have an infinite series that converges. So looking at the first example, it says determine whether the infinite series has a sum. If so, we're going to find the sum. If not, we're going to state why we can't add it. So if you notice, this example is not a geometric sequence. In order to get from one term to the next, we have to add 5. This is an arithmetic sequence. So we cannot add this infinite sum because these numbers keep getting bigger and bigger as well. When I add them up, it's not going to get to a point where those numbers get so small they're insignificant and we don't need to add them. Those numbers are getting bigger and bigger. So there is no way to add up an infinite set of numbers that are getting larger and larger. So this sequence diverges. And the reason is because this is an arithmetic sequence and the numbers keep getting bigger and bigger. Now for example 2, I noticed that this is a geometric sequence. To get from one number to the next, I keep multiplying by 5/3. So my common ratio is 5/3. However, this is greater than 1. And as we stated at the beginning, if it's greater than 1, then the series diverges. And so our reason why it diverges is because r is greater than 1. Looking at example 3, it says determine whether the infinite series has a sum. If so, we're going to find the sum. For example 3, it says determine whether the infinite series has a sum. If so, find the sum. So notice in this example, they're using k's instead of n's, which is fine. It's just a different letter. So the kth term is going to be a1 times r to the n minus 1. Notice a is 3, and r is 1/4, and then we have k minus 1. R, in this case, is 1/4, and that is definitely between -1 and 1. So this series converges, which means we can add this up. So although it seems a little abstract to be able to add an infinite number of terms, we can do this. So we're going to use the formula for the infinite sum, where we take a1, which is 3, and divide it by 1 minus r, which is 1/4. 1 minus 1/4 is 3/4. And then 3 divided by 3/4 is going to be 4, because we flip and multiply. We have 3 divided by 3/4, which is 3 times 4/3, and then I'm left with 4. So if I added all of these terms up of the entire sequence, eventually you're going to get to some term that it is so insignificant, from there on out, we don't even need to add it anymore. And then we would just add up all the terms up to that point, and we would get 4. Now, there is a way that you can do this on the calculator. Let me show you. So if I want to find an infinite sum on the calculator, what I'm going to do is go to my summation notation under the math menu. I'm going to scroll down, find my summation notation, and I'm going to fill everything in like I normally would. I want to start at x equals 1. But here's the thing, I can't put infinity in for my ending point. The calculator does not understand infinity. There is no infinity button for the calculator. So what we're going to do is we're just going to put in a really large number. And the number that I like to use is 1,000. That usually works for me, because eventually at some point, those values are going to be so insignificant, then when we add them in, it's not going to change the value of the sum. So I just put a really big number in there. Then I'm going to put in my nth term. So we have our first term is 3 times, and then our value of r is 1/4. And we're going to raise that to the power of x minus 1. Now I'm going to hit enter. Because we're asking the calculator to do 1,000 calculations, it's going to actually take a minute or two. So when you hit enter, you just have to be patient, but the answer will eventually pop up. And you'll see at the top of your calculator that the little spinny thing is going. So just be patient and let it go. And so it tells us that the answer is 4. So we can verify that by just using a really big number for our ending value. And typically, like I said before, typically 1,000 works. Now, if 1,000 doesn't work, you might want to go out to like 1,500, but usually 1,000 works just fine.